We're continuing with our study of Lesson 3.7. We're calling this, we're breaking this up into two different parts. This is part 2, and we're going to talk about two different types of problems in this lesson. You can see my first example there, 2a. The instructions are to solve these inequalities by graphing, and you're going to do the same type of thing on problems 4 through 7 and 20 to 30 even. Let's just jump right into the process here. First of all, I'm going to turn this around because it's, again, my preference to make these look like this. Just remember, if the inequality is pointing at the quadratic, it still needs to point at the quadratic after you switch these around. And we're going to look at this instead of an inequality initially. Let's think of this in terms of an equation. And the reason for that is, unlike our previous examples where we were looking for all of the xy coordinates, previously this would have said y is greater than x squared plus 5x minus 6. We were looking for all of the xy coordinates that made this particular inequality statement true. Well, now that it's less than 0, the quadratic is less than 0, what we're really after is, if we think of this in equation form, we want to first begin by thinking about solving the equation, because it's the solution of this equation that represents the x-intercepts, if there actually are any x-intercepts on this graph. Okay, so remember, the solution to a quadratic equation, which is finding out what x is to make this equation equal 0, and there's actually going to be two different numbers. Those two numbers are also the x-intercepts for the graph. Okay, so that's where it's going to start on example 2a and all of these problems where you're going to solve an inequality by graphing. See if you can identify x-intercepts first. And there are several methods that we know to solve a quadratic equation. This particular equation factors because we have factors of -6 that add up to +5. And it's the factoring then that leads us to the solutions. These two numbers, when it comes to the graph, represent x-intercept, or where the graph will cross the x-axis. So I put a dot at -6 on the x, and I put a dot at +1 on the x. Okay? Now, I'm not going to make you do a lot of points. We can get another easy point on this parabola because the y-intercept is -6. So we'll plot that in just a minute, but let's find out where the vertex is. We definitely need to find out where the vertex is located. And I want to show you a different way, if you know where the x-intercepts are, a different way for you to come up with the vertex. We know that the AOS has to be a line that is really right in between these two x-intercepts. It splits your parabola into two equal parts. So, knowing that my AOS has to be right in between these two blue dots, if I just knew how far apart they are, and I divide that number by 2, I will know exactly where the AOS is located. And if I know where the AOS is, it makes it pretty easy to find out the vertex. Okay? So, in between these two dots, there's 7 units. Alright, you just count the number of units. 1, 2, 3, 4, 5, 6, 7. And if you divide 7 by 2, you get 3.5. So my AOS should be 3.5 units away from these dots. Okay, right in between. So this line that I'm drawing represents the AOS, and it's the equation x is -2.5. It's a little bit of a review of what we've done previously. Well, the vertex is on that line. So my vertex has to be -2.5 as its x-coordinate. We just need to figure out what the y-coordinate is. Okay, so let's go back to our equation and let's drop negative 2.5 in place of x. So you can literally plug this into your calculator. Okay, and grab your calculator and you can make sure we agree. Parentheses, negative 2.5, close parentheses, squared, plus 5 times negative 2.5 minus 6. That gives me negative 12.25. Now I know exactly where the vertex is. And since I've got limited space, especially on the graph paper I gave you, I think it has 9 units. I'm just going to make these in 2s. Okay, so I can fit negative 12.25 pretty easily. So on this AOS, I'm going to go negative 2, 4, 6, 8, 10, 12, and then just a little bit more. And that is my vertex. Okay, so let's go ahead and plot the y-intercept. That's negative 6. And match it up. And now we can go ahead and sketch the parabola. Alright, so now we're about to answer the question, and since you have all this in your notes, I'm going to give myself a little bit of room here. Let me erase this work, and let's go back to the original problem, the inequality. So it's the graph that will help us basically answer the question, which is, what this is really saying is, when we look at this parabola and we're trying to identify x coordinates on this parabola that are located where the parabola is below the x-axis. That's really what this means. What are the x-coordinates on this particular parabola that fall below the x-axis? Well, you can probably tell that the parabola falls below the x-axis in between these two x-intercepts. Everywhere else, the parabola is above the x-axis. It's only between these two x-intercepts that the parabola falls below. So the answer to this problem, this inequality, the x's that are less than 0, or in other words, what are the x-coordinates that are on this parabola where it's below the x-axis, that's going to be all of the x's in between negative 6 and positive 1. So we'll show it like this, all x's such that, and we show between like this. Now I'm going to make one slight adjustment to my graph, and it has to do with the fact that instead of saying less than or equal to, it just says less than. Well, that means that these two x-intercepts really are not part of the solution. I've identified the x's as all of these numbers, but the two endpoint numbers should not be included because it says just merely less than and not or equal to. Okay, so for that reason, I'm going to make open circles for these x-intercepts. And you could have done that at the beginning, but and going forward, you might want to just go ahead and do them as you go, but I just wanted to go ahead and get to the graph and then just point that out at the end. Okay, so my final answer is here. But you're going to need to look at the graph, and if it's less than 0, you're looking, in this case, you're looking for points, the x-coordinates that fall below. If it had said greater than 0, then you're going to look at the x-coordinates that lie above the x-axis. Okay, well, let's take a look at another example. Same type of problem. I'm going to turn it around. We could try to factor this. So what we're doing now is thinking of this as an equation, because the equation, again, when you're trying to solve an equation, you're trying to find those values for x that make this true. And if there are numbers that make this true, if they're real numbers, then those represent x-intercepts. So that's what I'm trying to find now. By letting this be an equation, I'm going to see if I can solve it. Well, solving by factoring means that I need to change this into positive x squared, which means all the other signs are going to change. I'm looking at negative 12, factors of negative 12 that add up to negative 7, and there aren't any. So then I'm going to go to another method, and I'll just use what most people would use. I'm going to use the quadratic formula to solve this. Alright, so the opposite of b plus minus the square root of b squared minus 4 times 1 times negative 12. And all of this is going to go over 2 times 1, which is 2. Alright, so we're going to simplify, and let's find the square root of 97. Okay, calculator, the square root of 97 is 9.85. So the way I'm going to find these two x-intercepts, they're going to be irrational numbers, is I'm going to simplify 7 plus 9.85 and then add those together and divide by 2. And then I'm going to simplify 7 minus 9.85, subtract those and divide by 2. Okay, so calculator, let's get this x-intercept. That's 16.85, and then divided by 2 is 8.43. One of my x-intercepts should be about 8.5. Okay, now let's work on this one. 7 minus 9.85, and then divide that number by 2, and we get negative 1.43. So the other x-intercept should be about negative 1.5. Okay, so let's find, I'm going to erase this. Hopefully you have this in your notes. If not, you can pause and go ahead and get it. Okay, we found our x-intercepts. Now let's go ahead and work on the vertex. Alright, so my vertex, I'm going to just do the opposite of b over 2a. We could add these together and divide by 2. Since these x-intercepts are rounded approximations, I'm just going to go ahead and find the AOS using this opposite of b over 2a. So here I am, I'm looking at this. Really, you could look at either one, doesn't really matter. The opposite of b, which is in this one 7 over 2 times a. Alright, so it's going to be the opposite of negative 3.5, which is positive 3.5. Alright, so 3.5 should be the AOS, which is right in between those two red dots. And then the vertex, to get the rest of the vertex, 3.5 some y, we're just going to plug in. And again, you can use either one of these. I'll just go ahead and use that same one. The opposite of 3.5 squared plus 7 times 3.5 plus 12. So you can literally key into your calculator just like that. And let's see what we get. I got 24.25. Okay, so obviously we're going to need to make some adjustment to our y-axis here. I'm going to do this in, let's do 6s. Alright, so to show 24.25, here's my AOS line, so I'm going to go 6, 12, 18, 24, and then just a little bit more. Just above the 24 line. We can go ahead and get, just for guidance, we can plot 12 as a y-intercept and then match it up. So the parabola is going to look like this, but before we go ahead and draw it, we notice once again that these x-intercepts are not going to be a part of the solution. So we need to leave these open. Alright, so this should be an open circle. And same for this one. Alright, so let's just go ahead and sketch the parabola. Okay, and now it comes time to use the graph to help us basically solve the inequality. So let's get rid of all of this and just focus on the problem. Now again, the red is what's given, like was given in your book. I just turned it around. So what this says is I need the x values on this parabola where they are on the parabola below the x-axis, less than 0. All of the x's on the parabola that fall below the x-axis. Okay, well let's start off with where they're above the x-axis and then we'll work from there. Above the x-axis would be all of these points. All of the ordered pairs. In particular, we're looking for x coordinates. Hopefully you see that the red line represents where the parabola falls or lies above. So those are not the solutions. Kind of working backwards a little bit to show you what's not, so maybe it makes a little more sense. Well, what is a solution? The x values that represent the coordinates below on the parabola that are below the x-axis are over here forever and over here forever. Everything outside of the parabola, because down here we're below and we'll continue to be below. Same thing over here. So how do we write this in inequality form? So we want to know all of the x's such that the values for x that are less than negative 1.43, that's all of these numbers. And then we'll just break this up into two parts. All of the values for x that are greater than 8.43. That's all of these numbers. So I just used the green arrow matched up with the inequality to hopefully help you see the numbers, the x coordinates for this particular parabola that fall below the x-axis. Alright, let's try another one. Okay, so here we are again with this quadratic. It's let's look at it as an equation. And solve it. So we can determine if we have x-intercepts, where would they be? I do notice that there's a GCF here. I'm going to factor out 2 as a GCF. Erase that. It should be 2x squared. Plus 6x plus 5. Just to see if maybe there's a way of factoring this trinomial in the parentheses. So here's how you can tell. if you multiply the first and the last together, that's 10x squared. And then just ask yourself, are there factors of 10x squared that add up to 6x? And there actually are not any factors of 10x squared that add up to 6x. So we need to work on solving this using another method, like the quadratic formula again. So I'm just going to take this trinomial in the parentheses and solve for x using that trinomial. So the opposite of b plus minus the square root of b squared minus 4 times 2, which is 8, times 5, which is 40, all over 2 times 2, which is 4. Well, I notice that this is one of those cases where I have a negative discriminant. Okay, and I'll just get down to this point. And what do you remember what this means as far as our graph is concerned? When I have a negative discriminant, which means I'm going to have two complex number solutions, this represents a graph that is never going to cross the x-axis. Well, let's pay attention to how it opens. Since the number in front of x squared is positive, it has to open up. Therefore, if this graph never crosses the x-axis and it opens up, then the vertex has to be somewhere above the x-axis. Okay, if it were below the x-axis, then we would have to cross, and this parabola is never going to cross. So let's go ahead, and now that we know that we're never going to cross, we still need to go ahead and come up with the graph. But hopefully you see with that negative discriminant, we're not going to have any x-intercepts. So let's find the AOS. And I'm just going to go back to the original opposite of b over 2a. And if you reduce this, 4 goes into 12 3 times, 4 goes into 8 2 times. So the AOS is the line x equals negative 1.5. On that AOS line we have the vertex, and if we want to know the vertex, then we plug negative 3/2 back into our original. Okay, so let's see what the vertex is. 4 times negative 3/2 squared plus 12 times negative 3/2 plus 10. You might want to grab your calculator. I think I'm just going to do some mental math here. Negative 3/2 squared is 9/4. 4 times 9/4 is just 9. This is negative 36 over 2, which is negative 18, plus 10. So we end up with negative 9 plus 10, which is positive 1. So my vertex is the point negative 1.5, 1. Alright, and the only other point I'm going to use is the y-intercept, which is 10. For you, that's just one more point than you have. So you can just make a dot at the top on that bigger graph paper. Alright, so that's 1.5 to the right, so 1.5 to the left. Alright, so I'm going to go ahead and rough sketch this parabola. And now the question is, the parabola, or the inequality says, what are all the x values from coordinates on this parabola that fall below the x-axis? Well, this parabola never falls below the x-axis, and it never will. It opens up, and the vertex is above. All of the points on this parabola are above the x-axis. None of them are below. So this is one of those situations where we have no solution. Okay, it wants the x-coordinates from points on the parabola that fall below, but there aren't any for this parabola. So hopefully that makes sense to you. And I believe that's it. And now the other type of problem that we're going to deal with, this is my third example, the directions are going to be to solve algebraically. So you do not have to graph these as far as a regular XY plane graph. Okay, so we're going to start off very much like we did previously. We're going to treat this as though it's an equation for just a minute. And we're going to find out what the solutions are, if there are any real number solutions. Factoring, if possible, is to me the best way. The factors of negative 16 that add up to positive 6 are positive 8 and negative 2. And so my solutions are negative 8 and positive 2. Okay, so we're going to take those two numbers that represent solutions to the equation, and we're going to put them on a little number line, and we're going to do some testing. And here's what we're going to do. When you solve algebraically, you find the solutions, if there are any, and then you're going to test numbers from each of these three sections. Okay, our numbers here represent a number line that's divided up into three parts. We're going to pick a number that falls in this section. Doesn't matter what it is. I typically just do the next closest thing. I'm going to pick negative 9. Okay, and I'm going to plug negative 9 back in to my original inequality. And my goal is to see if negative 9 makes this a true statement. So let's see. Negative 9 squared plus 6 times negative 9 minus 16. Is that less than 0? Well, let's see. Negative 9 squared is 81. 81 minus 54 is 27. 27 minus 16 is 11. 11 is not less than 0, so what I've just proven here is none of these numbers less than negative 8 are part of the solution. So now we're going to pick a number in between. Doesn't matter what number you pick. Choose the easiest one to work with, which is usually 0. Okay, so let's choose 0 to test. 0 squared plus 6 times 0 minus 16, is that less than 0? Well, negative 16 is definitely less than 0, so what we've proven here is the numbers in between negative 8 and 2. Now we're not going to include negative 8 or 2 because it says just less than, but the numbers in between are part of the solution. Alright, so let's keep going, and now let's pick a number from this other section, like 3. So let's see. If we let 3 go in for x, 3 squared is 9, plus 6 times 3, which is 18, minus 16, is that less than 0? Well, we get the same answer as we got earlier. 27 minus 16 is 11. 11 definitely is not less than 0, so these do not work. So my final answer are these numbers in between negative 8 and 2 that we found with 0 does make this inequality a true statement. So here's my final answer. All x's such that the x is between negative 8 and 2, and we're not going to include negative 8 or 2 again because it doesn't say or equal to. So that's my answer for letter A. Let's try letter B. Solve algebraically. I'm going to turn this around. I'm going to make it equal to 0. Now I'm going to treat it as an equation to come up with the solutions. Okay, the specific numbers that would make this equation, this trinomial, quadratic trinomial, equal 0. And once again, factoring is possible, so that's the easier way to come up with the solutions. factors of 30 that add up to 11 are plus 6 and plus 5. So my two solutions are negative 6 and negative 5. And once again, we're just going to make a little number line. And we're going to do some testing. Our number line is broken up into three parts. So you can kind of think of it this way. The numbers less than negative 6, the numbers between negative 5 and negative 6, and then the numbers greater than negative 5. So I'm going to choose negative 7 as my test. Will it make this inequality true? I guess we'll go down to this one where I've made it greater than or equal to 0. Technically you could use either one. Okay, so let's see, negative 7 squared plus 11 times negative 7 plus 30, is that greater than or equal to 0? Negative 7 squared is 49 minus 77 plus 30. Let's see, that's negative 28 plus 30 is 2. Is 2 greater than or equal to 0? Certainly is. So the numbers that are less than negative 6 are going to make this inequality statement true, because we found one number that makes it true, therefore they all have to make it true. Okay, let's try a number between negative 6 and negative 5, like negative 5.5. I'll just come down here. So I'm plugging into my inequality, negative 5.5 squared plus 11 times negative 5.5 plus 30. Is that greater than or equal to 0? Okay, might want to grab your calculator for this one. Negative 5.5 squared is 30.25. And then we're going to have 11 times negative 5.5. That's negative 60.5 plus 30. Is that greater than or equal to 0? 30.25 minus 60.5 is negative 30.25 plus 30. Well, that's going to give me negative 0.5, which is not greater than or equal to 0. So the numbers in this range do not work. So let's try a number to the right, or greater than negative 5, and 0 is the easiest. So we can probably do that mentally. 0 plus 0 plus 30. 30 is greater than or equal to 0, so all of the numbers in this section do work. So now we need to come to a conclusion. What is our final answer? Well, all of the numbers less than or equal to negative 6, because it says or equal to. So x is such than, x is less than or equal to negative 6. And then over here, the numbers greater than or equal to negative 5. And that's my final answer. And I've got one more. Okay, same instructions, solve algebraically. So let's see, negative 4x squared plus 2x minus 3, and I'm going to go ahead and make this equal to 0. So to begin with, just turn this into an equation that equals 0, and then see if you can come up with the solutions. I know this doesn't factor, so I'm going to jump into solve by using the quadratic formula. The opposite of b plus minus the square root of b squared minus 4 times a times c. All of this is going to go over 2 times a, which is negative 8. So again, do all this multiplication first, and you get negative 16 times negative 3, which is 48. and 4 minus 48 is negative 44. Okay, well once again we've got this issue of having a negative discriminant, which means this particular graph, if we were graphing, is never going to cross the x-axis. So even though we're not going to, and we don't have imaginary numbers that we can plot on a real number line. So we're going to have to think about this one for just a minute, and even if you have to do a rough sketch, it's okay. What do we know about this parabola? Well, we know it opens down, alright? And it's never going to cross the x-axis because the discriminant is negative. We have no x-intercepts. Well, the only way to have a parabola that opens down that never crosses the x-axis is to either have it like this or like this. You get the picture. And it's really not even necessary to come up with AOS. You don't have to come up with the graph, but I'm just doing this as an illustration. Now, what this wants to know is what are the values for x? I'll turn this back into inequality. What are the values of the x-coordinates on this parabola that fall below the x-axis? Well, they all do, because it's got to be a parabola that looks like this, opening down and cannot cross the x-axis, negative discriminant. So therefore, all of the points on this parabola fall below the x-axis. So this is one of those all real numbers cases. So I hope that makes sense. All right, and that's all I've got for you. We're going to work on these in class, so you can send me an email if there's something about these examples that you don't understand. I hope you took thorough notes and come to class tomorrow with questions and be ready to practice these concepts.